Okay. So what we're going to learn today is functions versus relations. They didn't talk about relations in the chapter, I don't believe. But the homework that was due today was a little confusing to several people, but functions are an extremely important thing to learn about in algebra. You will actually 90% of what you've done so far are sorry. 90% of what you've done so far have been dealing with functions. Okay, maybe actually almost 100%. But we haven't talked about what functions actually are, and they are the foundation of calculus. So to understand functions now is going to be really, really important. And you're going to see a different way to write an equation of a line in what's called function notation. Okay? So we're going to talk about relations versus functions. So this should be in your notes. You should write this down. This is note-taking time. So relations versus functions. So for here you see what they start. You guys remember T-chart?
Yeah.
Right?
It's like a horizontal.
So,
it's like a T.
All right. So let's create an equation, and let's just start to see what a T-chart actually is. We'll dissect it a little bit more because we haven't talked about it a whole lot. Okay. Y is equal to x plus 5. Okay, so I'm going to do my T-chart. X, Y, and I always start with my x, right? I choose my value for my x. You agree with me? Alright, so I'm going to say 0, 1, and 2 are my values for my x. And then I'm going to figure out what y is when I plug these in. So if x were 0, what would y be? If x were 0,
5.
5.
Cinco.
Okay.
De Mayo.
Okay. If x were 1, Tiana, what would y be if x were 1? 6. Good. And Isabel, if x were 2, what would y be? Okay, 7. All right. So this is a T-chart. We inputted the x's. We decided what to make for the x's. The output was the y's. Does that make sense? The way this is written, this is like a machine. If you put a number in for x, it'll spit out a y. So this is your input. So your x is your input. All right? And your y is your output. Okay? You with me so far?
It makes sense.
It makes sense. Go ahead.
Like, well, it's not really that it makes sense. Like, I can remember it because, like, you say x before y, like x and y, right? And when you say input and output, you say input first. Yeah, you know.
Yeah. Oh, yeah. That's great. That's a good way to think of it.
Yeah.
That's awesome. Good.
I know.
Good. Now, what are you guys from the reading last night? You learned a vocabulary word for what all the x's are. They're inputs, but they're also something else, Nicholas. They are the domain. So the domain represents all the possible
And then the range.
What are you doing? So have a seat right here. So the domain are all the possible x's. Okay? And the range are all the possible y's. You guys remember this from the reading? All the possible y's. Yes. Yes.
When we're reading when I'm reading in the book, it's really, really hard to understand.
I know.
Like, I know, and the grammar is wrong.
Okay, so maybe talk to me after. Let's talk about that afterwards. But I'm in this lecture right now. Let me just do this right now. So all the x's are considered your domain, and all the y's are considered your range, right? So what are, well, when I write an equation like this, right? Let's say I graphed this. If I graphed this, okay, so it's a 1, 2, 3, 4, 5. Put a dot there, and I go up 1, over 1. Put a dot there. This is my graph for this equation. It goes on forever. Would you agree with me? And because of that, what is my domain here? Where does it? What can x not be? Is there anything that x cannot be? Think about it. I could go over here. This is my x-axis, right? I could go way over here. Is there going to be a y somewhere?
Yes.
Right? There. If I go here, there's a y right here. If I go here, there's a y down here. If I go here, there's a y way down here. If I go over there, the y is way down. It goes on forever that direction. What about this direction?
Oh, yeah.
If it goes here, there's a y there.
Forever.
If I go here, there's a y way up there. If I go way over there, the y is like way up there. There's no boundaries for the x. X would be, the domain for this equation would be all real numbers. So if I were asking you what is the domain of this equation, you would say the domain is all real numbers. Right? Whoops. Numbers. Okay, all real numbers. That's the domain. And what about the range? If I go down here, there's an x. If I go up here, there's an x. If I go way up here, there's going to be an x way over there. Way down here, there's going to be an x way over there, right? So the same thing is true for the range. The range is all real numbers. Right? Does that make sense so far?
Yeah.
It's a little confusing because it's sort of new. It's new information for you, but it's really not that hard. Remember, domain is all the possible x's. Are there any things that x's cannot be in this? No. If x were 0, there's a y. If x were negative 1,000,000, there's going to be a y that goes way down. If x were positive 1,000,000,000, there's going to be a y way up there. The line goes on forever, right? All right. Now, things change when you have different kinds of graphs. We'll get into that eventually. But you're not always going to have this as your answer. But in the book, they did a T-chart, but none of you probably recognized it as a T-chart. They did a horizontal bar chart, right? And that is the same thing as a T-chart. All right? So, for example, well, let me just see what they put. Okay. Does anybody know when I started this video? I forgot to have you guys.
Started like a long time ago.
Okay, 8:42. So it's been 9 minutes. Can somebody time 6 minutes because this ends in 15 minutes.
All right. So it's 10:56 right now. So and at 11 or
10:02.
9. It's 9.
Right. So 10:02.
So
Right?
10:02. I don't know how to read an analog clock.
Okay, guys, I'm gonna have to move you guys. So Tiana, come and sit right here for now. Okay. All right. Well then, what were you talking about?
Yeah, neither of us were talking.
Okay.
Doesn't matter.
Just move for now. Just move for now. Okay.
Doesn't matter if you're or not.
We don't want to talk.
Guys, I am in the middle of a presentation right now. Do not argue with me in the middle of a presentation, right? So smooth. I was watching you guys, okay? So, all right, we have relations versus functions. Now I lost my train of thought. In the book, they do this. They had input and output. Okay, and they had something like this, I don't know, 10, 20, 30, 40, and this was, you know, 4.6 and 8.2 and, you know, whatever. And so, well, I'll just keep going. 10.5 and 1.1. All right, this is an example of a T-chart sideways, okay? Your input, you always have your X on top and you have your Y on the bottom. So it's just the same thing as a T-chart, just horizontal.
Gary, you put 1.1 to make it bigger.
Yeah, you should. I put it there for a reason. You'd think it would, right? Because if it were a function, it would have to grow in proper terms, right?
Mm-hmm.
So the question is this a function? Well, actually right now, the way it's written right now, you would actually say, yes, it is a function. There is a definition of function that you have to understand. It's really, really key. This is the definition. Did I put two N's there? Sorry. In order to know if something is a function, this is what you need to know. For every x, there can be only one value for y. There can only be one value for y. Okay? So, in this chart, do I have any repeats here? I have 10, all I have to look at is my x's.
No, there's no repeats.
There's no repeats. 10, 20, 30, 40. All right, now I'm going to look at the values for y. This has a value of 4.6. It only has one value. Okay, so far we're a function, right? There's only one value for x in the y's. All right, this is a different x, 20. There's only one value. Okay, that's a function so far. I mean, we're getting there. There's only 130, and it's got a different value. I mean, it's got one value. There's only 140. It's got a value. Therefore, this is actually technically a function. And I don't know how they all relate together, but they're functions, right? Now, the problem, though, is when you have something like this. Let's say you have this. One, two, three, 4, 2. And I have 10, 20, 30, 40, 50. All I have to do to tell, if I asked you, if you got this problem on an exam that said, does this this chart represent a function? All you do is look at the x's. You look at the x's only. 1, 2, 3, 4. If that was 5 or any number other than one of these numbers, it would be a function because it would only have one value. But notice the 2's are repeated, right? Mm-hmm. The 2 has two different values. The x, when x is 2, I could either have a value of 20 or I could have a value of 50. It's not a function. Alright, so let's just see what a function looks like. A function is pretty much everything you've been working with. A straight line is a function. Okay? But an example of a not a function is what if I did this? Let's say I had a rectangle. I have a rectangle. For every x, let's say I go right here. At this point where this x is, I have a y here and I have a y here. I have two values for the same x. It's not a function. It's still a shape. We would call this a relation. They're related, but they're not. That's not a function. For it to be a function, there can only be one value of y for every x. Okay? Yes.
Input-output graph thing that you just made. What if you had like 1, 2, 3, 4, 5, and then as your domain, and then as your range you had 10, 20, 30, 20.
Ah, good question. Okay, let's try that. So let's say we had 1, 2, 3, 4, 5, and you had 10, 20, 30, 40, 20. So the y's were repeated. That's okay. It's still a function. All it matters is for every x, and right here, there are only 5 x's. My domain in this is what? It's 1, 2,
So that
3,
counts as a
4,
function.
and 5. That is a function. Because there's no repeats in my x's. Make sense?
I was trying to figure out, like, why is it that it's one way but not the other? 'Cause it's just like, it's
Okay.
adding one way and subtracting the other, and you get
Right.
the same thing.
Right. So there's a thing called let me just draw a couple more examples of things that are not functions.
Gary, you gotta stop your video.
It's
Oh!